All right, this video is going to go through the very first part here of our last set of information. So here we go. Chemical reaction. That RxN is just simply a abbreviation for reaction. It's a reaction is simply where you put two things together and you get something out the end. Chemical equation. The difference between a chemical reaction and a chemical equation, except in a chemical equation we're going to use symbols and formulas. The chemical reaction just uses words. So it's just a way of how we represent what's going on. Okay. The parts of a chemical reaction, there are two of them. The first one is things that are present at the beginning, which are our reactants. Those takes place in the beginning. Letter B, produced at the end. Those are our products. Okay. Now this example here, the octane and the oxygen, those are going to be your reactants. They're in the beginning part. Sorry, I spelled that wrong. And at the end, we're going to end up with our products at the end, the water and the carbon dioxide. Exothermic reactions is a reaction in which energy is released. They get hot. So like whenever you use hand warmers, and you shake them up or you punch the little dot and they get hot, that's an exothermic reaction. That's how they work. Endo on the flip side of that would be where things get cold to the touch, and that is when they absorb energy, and that's how they feel cold. 3 requirements for a chemical reaction. They must represent the known facts. It's got to be true. The equations must contain the correct formula. So H2O, it has to be H2O. Water is not H4O, okay? It's got to be true. The formula has to be true. Conservation of mass must be satisfied. Conservation of mass says that matter or mass cannot be created or destroyed. So if you start off with 5 grams of oxygen, you need to end with 5 grams of oxygen. Coefficients, small number used to balance equations. The balancing, that's what we're going to do, is simply making the law of conservation of mass true. So I'm going to make sure if I have 5 oxygens, I'm going to end with 5 oxygens. And so the coefficient is what we use to balance, and it's just like a coefficient in math, okay? If we have H2O, the coefficient is the big number out in front, okay? So 2 in that case would be the coefficient. All right, let's balance. Okay, now the only thing with balancing is that they can get kind of frustrating because there's no nice and easy mathematical equation for it. It's all done by trial and error, so that can make things a little frustrating if you can't get it to work out. Okay, but we'll go through some tips and techniques to help you not get frustrated with them. Okay, so first things first, what is balancing? Okay, again, atoms are not created or destroyed, we're just rearranging them, but the total number of atoms has to be the same on the reactant side as the product side. Okay, so same thing, number in each type is found in the reactants and the products. The formulas cannot be changed when you balance. Okay, you cannot change water to H4O. Okay, you can't change those subscripts. Okay, you can't do anything to a formula. So then what can you change? And that's this big thing here in asterisk. The only thing you can change is the coefficient that is out in front. That's it. Everything else, don't touch it. Okay, so here, let's go ahead and do a problem here. To start off with, the best thing that you can do is what's called an atom inventory. And I'm simply going to make a list of what atoms I have, what are the types, and then how many. So for example, I'm dealing with zinc, so I like to write it in the middle, okay? So I know I'm dealing with zinc. I also have sulfur, and I also have oxygen. Then on the left side, I'm going to write how many of that element or that I have. So for example, zinc I have 1, sulfur I have 1, oxygen I have 2. Do the same thing on the other side. Zinc, I've got 1. Oxygen, there's 1 oxygen from the ZNO, but there's also 2 oxygens over there. So I have 3 oxygens. and then my sulfur is 1, okay? And so I need to have the same number on both sides. So right now, zinc and silver are balanced because they're 1, 1, okay? But oxygen's is not. So what I'm going to do is I'm going to get rid of that odd number of a 3, get some nice even numbers. So I'm going to try, and it's all trial and error, I'm going to try to put a 2 out in front of that ZNO. Now, that 2 gets distributed both to the zinc and also to the oxygen. So, updating my atom inventory, I now have 2 zincs, and my oxygens, I've got 2 from the ZNO, but I still have 2 over there from the SO2, which is going to leave me with 4, okay? But now as I look at it, if I go back up, my zinc is no longer good because I got a 1 and I got a 2. They're not the same. So I'm going to try a 2 over by the ZNS all the way off over to the left. And again, that gets distributed through. So now I have 2 zincs and 2 sulfurs. Awesome, zinc is good, but sulfur is no longer good, okay? So I'm going to try to put a 2 out in front of the SO2. And that'll leave me with 2 sulfurs, and the oxygens will now be at a total of 6 because that 2 gets multiplied by that O2. So you get 4 oxygens there, but you still have the oxygen from the ZNO. So that's how we get 6, okay? So zinc is good, sulfur is good, but oxygen is not still, okay? And so I've got my O2, and I need it to be 6. I need a total of 6. So that would make this a 3 O2. And that would change that to a 6. So I've got 2, 2, 2, 2, 6, 6, all the same on all sides. It's good. It's balanced. Okay. That was a little bit more of an involved one. Okay. Let's make it a little bit easier here now that you kind of see the general pattern for this. So again, I'm going to write my atom inventory, write what elements I'm dealing with. So I've got nitrogen and oxygen. Count out how many I've got on each side. Nitrogen, there are 3. Oxygens, there are 6 of them. On the flip side, 1 nitrogen and 2 oxygens. So I need to make a 3 for my nitrogen. So I'm going to put a 3 out in the back side. And now I'll have 3 nitrogens and 6 oxygens. 3, 3, good. 6, 6, good. It's balanced. Now, leave these parts right here blank, okay? Do not put a coefficient in there. A coefficient of 1 is actually incorrect. It's assumed that if there's no coefficient there, it is 1. And it is actually incorrect if you were to put a 1 there. So leave them blank. Don't do anything to those 2 reactants. Next one. I'm dealing with Hg, mercury, and oxygen, 1, 1. 1, 2 on the other side. We'll put a 2 in front of the HGO, and then we'll need a 2 in front of the mercury. And that one's good. All right, here comes a little tip here, and has to do with the polyatomic ions. So starting off here, okay, oh, get rid of these wacky lines that just appeared. I am dealing with sodium, chlorine, copper. Now, the lovely NO3. NO3 is nitrate. It's a polyatomic ion. So the tip that you can do is if you see NO3 on the backside, which is right there, as long as they're the exact same, instead of breaking it up into nitrogen and oxygen, we're going to write in our atom inventory NO3, and we're not going to break it up. And that'll make balancing a little bit easier. But it has to be the same polyatomic on either side. It can't break up or anything in order for that trick to work. So counting our atoms, 1 sodium, 1 chlorine, 1 copper, and again that 2 goes to that NO3. So we have 2 NO3 on the backside, 1 sodium, 1 NO3, 1 copper, 2 chlorine. So let's go ahead and get this done. Sodium is good. Chlorine, I need a 2. So I'm going to put a 2 in front of that NaCl. But now I have 2 sodiums. But now my chlorine is good. Go back, fix the sodium. 2 in front of the NaNO3, which will make that 2. And then this 2, again, because we're not splitting this up, is going to go to that entire NO3. So I've got 2. And now everything is balanced and looks good. Okay. All right, next one. MgHCl 111 across the board, magnesium 1, chlorine 2, hydrogen 2, and I need to have 2 hydrogens, and now I have 2 chlorines, and it's good. And that takes us through balancing equations. And so now it will be time to practice on your own. Good luck.